Hi guys, this is the third video in the module of functions, and in this video we're going to start looking at different types of functions. Specifically in this video we're going to look at three types of functions: one-one, many-to-one, and onto functions. So let's go ahead and start to look at it. So what are the type of functions that we're going to discuss in this module? There are totally 5 types of functions: one-to-one, many-to-one, onto, even, and odd function. Now there is an inverse of a function which is not, I don't know whether you can call it as a type of function or not. We are also going to discuss that, but in this video we're going to look at the first three. So, well, as I said, we will not be looking at many other types because we are keeping it for the entrance exams that are required, like IPMAT or DUJAC. We are not looking at doing a PhD in this. So we will restrict ourselves to these only. So in the type of functions, we will start understanding the first one, which is a one-to-one function. Now recollect the definition of a function. Obviously, I'm talking about a function calling or being called one-to-one. So first of all, it should be a function. So it should be satisfying the two criteria of function, which I've discussed in the previous video. I hope you remember that. On top of that, it should be something extra. What is that extra we're going to look at to be called as one-on or one-to-one? Okay, so what is a one-to-one function? A one-to-one function is also called as an injective. Please note the name. It is also called an injective function if every element of the range of G corresponds to exactly one element to the domain of G. So let's forget about the definition technically. Let's understand concept. What is the meaning of it? Okay, I'm never a fan. I've never been a fan of textbook definitions. As long as you understand the concept, that is enough. So what exactly does it mean? It means every element of the range of G corresponds to exactly one element of the domain of G. So you should not have, so this is a perfect example you can see here. So every one element here is mapped only to one output. One element mapped only to one output. I'll show you a counter example for you to understand this better. This is not called as a one-to-one. You can see this is not called as a one-to-one. Why? Because the output here has two inputs and that is not allowed. So one-to-one basically means one element here, one element here. It's as simple as it. Very simply think of it like this. One element in the input maps to only one element in the output, nothing else. So obviously by the definition of a function, this is not possible. One cannot have two outputs. That is anyway ruled out because a function cannot do that. If you remember the second video of functions. Now, while this is allowed, this is a function. It is a function, but it is not a one-to-one function. One-to-one means one versus one. That's it. That's the mapping. Okay. This is a definition of a one-to-one function. Don't worry about by hearting the definition. Nobody's going to ask you to write the definition except for your board exams. No competitive exam is going to ask you the definition. It's going to apply the definition, make you solve questions based on that. Anyway, so how do you prove that one-to-one function or a function is one-to-one? It's very easy. We have a test called as horizontal line test. If you remember, we did a test for function, which is a vertical line test. We discussed this in the second video. Right now, we have a similar test, but it is a horizontal line test. And the test is very simple. Take the graph, if the graph is available, obviously, and draw a horizontal line. If the line cuts the graph more than once, it is not a one-to-one function. If the graph cuts the line more than once, it is not a one-to-one function. Okay, look at these. Which of these is a one-to-one function? Pause the video, take a look. Those of you who have done it, check your answers. First one is not a one-to-one function because any line I draw, it is intersecting in 3 points. It is not a one-to-one function. The second one is clearly a one-to-one function because any horizontal line I draw cuts only once. And the third one is again not a one-to-one function because it is cutting it more than once. In fact, if you recollect, this is a function because any vertical line I draw cuts it only once. This is also a function because any vertical line I cut draw cuts only once. This is not even a function. This is not even a function because the vertical line is also cutting twice. So first of all, if it is not even a function, it cannot be called a one-to-one function at all. It could be called a one-to-one relation, but that also it fails because the horizontal line test is failing. Okay, well, that's about your one-to-one. The second method is, what if the graph is not available? Now I always tell you the easy parts. Now the difficult part. What if the graph is not there? Then it becomes a little bit tricky. What you will do is you will take the expression given to you, which is a function, calculate f of 1, calculate f of 2, or f of x1 and f of x2, my mistake, and then equate them. And if you end up getting x1 equal to x2, then it is called as a one-to-one function. If you get something like this or any other possibility, it is not a one-to-one. Now this might look a bit confusing, so let me explain this with the help of an example. Look at this. This function, is it one-to-one or not? That's what I want to check. So I will start with f of x1. This is x1 modulus minus 1 by modulus x1 plus 1. And I will say this is equal to f of x2. So f of x2, if I want, what will it be? It will be modulus x2 minus 1 by modulus x2 plus 1. Now, if these two are equal, that's what I'm supposed to do. I will cross multiply. If I cross multiply, what do I get? Modulus x1 modulus x2 minus modulus x2. Then I get plus modulus x1 minus 1 is equal to modulus x1 modulus x2 plus modulus x2 minus modulus x1 minus 1. Now negative 1 gets cancelled. This product will get cancelled. What am I left with? I am left with, I will get this to the right hand side and I'll get this to the left hand side. So 2 modulus x1 equal to 2 modulus x2. 2 can be cancelled. I'm left with modulus x1 is equal to modulus x2. For those of you who know the basics of modulus, you can write this as x1 equal to plus or minus x2. This clearly tells me that it is not a one-to-one function. The condition is, when I do this, the simplification, I'm supposed to get x1 equal to x2 and no other possibility. This should be the only possibility. If there is a second possibility for x1, I could, if I'm saying x1 is 0 or x1 equal to minus x2 and 0 both simultaneously, obviously it will be called as it will not be called as a one-to-one function. Okay, so here it is not a one-to-one function. I explained the concept to you on how to check a function using this example. Right, moving on. The next type of function is many-to-one function. Now, what is a many-to-one function? A function is said to be many-to-one if at least two elements of the domain are mapped to the same element of the codomain. So you can see here in this example that both -4 and +4 are mapped to 16. So many inputs are giving you one output. That is the meaning of many-to-one. What is the meaning? Many from the left hand set, which is a domain, mapping to 1 in the codomain, which is allowed. As a function, it is allowed, right? So this is called as a many-to-one function. Now, how do you test for a many-to-one function? It is actually very simple. First, you have to check whether the given relationship is a function or not. That is anyway you're supposed to do. Then actually check for one-to-one. So a function is either a one-to-one or a many-to-one. It is either a one-to-one or it is a many-to-one. It's a binary, 0 or 1. It's this or that. So if it is not one-to-one, it must be many-to-one. Now it's a small homework for you if you're interested. Why should it be like this? Why should a function be one-to-one or many-to-one? Why is there no other possibility? You can think for yourself. Okay, but I will leave it as a homework. You can put it in the comments. If you don't get it, I will respond. But right now, understand that the function, a function which follows the definition of a function, will either be a one-to-one or it must be a many-to-one. If it is not one-to-one, which you know how to check, automatically it must be a many-to-one. That's as simple as it. Okay, we are going to now look at the next type of function, which is called as an onto function. So let us understand what is this animal called onto function. Okay, so an onto function is, first of all, notice that it is also called a surjective. It's another name given. I don't know why they give so many names, but yeah, it's there, so you have to learn. A function from A to B is called a surjective or an onto if for every element of B there exists an element in A such that f of A is B. This is a textbook definition that I picked up. Let's not worry about this. Don't worry if you don't understand this. Let us understand in the layman's terms. Basically, it tells that every element of the codomain has a mapping from the domain. That's what it says. Therefore, the range in the codomain are same. Now let us see a graphical or a visual example. You can see here that in the first case, every element of the codomain has a mapping to your domain. So the first one will be called as an onto function. Now in the second case, you can see that one element in the codomain is left out, which means the C here does not have a mapping. So this will not be called as an onto function. This will not be called as an onto function. It's as simple as that. So how do you show that the function is onto? Basically, to show a function is onto, again, there is a English way of it. I'm just explaining the concept, the meaning of that. Basically, what you're supposed to do is write y in terms of x and say that this y is always possible. This y is always possible. Let's take an example to understand this better. Let's start with this. Function f is mapping from, what is q if you remember? Q is rational numbers. So a rational number to a rational number. Always keep in mind, it's a rational number to rational number. And it is given by 4 minus 2x cube. Now I need to check whether this is an onto function or not. So what will I do? Is it a surjective function or not? So what will I do? I will start with taking this as y. And I will write x in terms of y. So I will get it in this way. Now my job is to find out, will x be a rational number for every y which is a rational number? Because my x should come from rational numbers. My y should come from rational numbers. So can I put any y in this which belongs to rational numbers so that my x is a rational number now? And very clearly you can observe that this is not possible. If I say, for example, if y equal to 0, then you can see that x equal to cubed root of 2. And this is not a rational number, right? This is not a rational number. So because I have at least one y in which my x is not a rational number, then automatically I will say that this y equal to 0 is not possible. And if y is equal to 0 is not possible, it means it is not covering all your rational numbers. And because 0 is an integer and 0 is a rational number, all integers are rational numbers. Hence, it fails the test of onto. So once again, remember, how do you prove a function is onto? You convert x in terms of y and show that for every y that belongs to your codomain, your x is happening in your domain. If this relationship is not happening, certain y will not give you a proper x, then it means that function is not a onto function. Simple enough, right? So hence you will say it is not a surjective. Well, friends, that's the end of the video for this particular one. In the last video of the module, we're going to take up even function, odd function, and then we're going to discuss the inverse of a function. Thank you and see you in the next video.